let's get this done. Chapter 5.6, rational functions. One sec. Sorry, I'm stressing out now. Things not working right, so hard candy. Although technically it's some cheapo vitamin C something. I prefer butterscotch. All right. So I is irrational but well-rounded. That's the first thing in the notes, so that's what I'm going to be saying. Anyways, f of x equals p of x over q of x. And this is a rational function. Making sure it's properly visible. Maybe if I swap the legs. No, that's not any better. Whatever. Just got to get this done. All right, so f of x equals p of x over q of x is a rational function where p of x and q of x are polynomials, and q of x cannot equal 0. The domain is all real numbers except the zeros of q of x. All real numbers except the zero of q of x. I'm probably never going to be a teacher, thank God. I do not think anyone would learn anything from me teaching math. Now, for example, f of x equals 3 over x squared minus 4. Right, so root property, x squared equals 4. If we're setting x squared minus 4 to 0. So we square root it, and we square root this. X equals 2. But it's not just 2, because there are 2 results for the square root. It's positive or negative 2. So x is 2 x is negative 2. And this cannot be 0. We set it to 0 to figure out what x might be. But, as already stated, this, the end result of what this is, cannot be 0. So let's do... Oh yeah, I'm overthinking it. So, this is our answer for what it can't be. It cannot be positive 2 or negative 2, because the end result would be 4 minus 4 equals 0. And that does not work because, remember, this can't be 0. So the domain for this equation, I think this marker is worse than I thought, is all real numbers except for 2 and negative 2. Now, how do we show that? How do we write that down for, let's say, what this is most likely going to be used for, graphing? It's pretty simple. It's all numbers. So if it wasn't the case that 2 and negative 2 can't be it, then it would simply be put in function notation, if I'm remembering the name correctly, in negative infinity to infinity. That's what it would be. But it can't be that because it can't be 2 or negative, meaning there's a stopping point. So, what happens then? God damn, this is just horrible. I'm going to properly mark this down. Yes. Is that any better? Whatever. It's just going to be step blue. So, back to the topic. So how do we write that in function notation? Well, we know that it goes all the way to negative infinity. We know that one for a fact. But it can't go to the right and hit negative 2. So instead, what we put down is negative infinity to negative 2. Then we put a u. I'm just used to making the giant u's with a tail, but for the sake of this, I'm not going to do that. Then it's all numbers between negative 2 and 2. Another u, and then it's 2 to infinity. It's fine, it's fine, it's fine. That's how we write the domain in function notation. Now, vertical asymptotes. Stop opening photos. Vertical asymptotes. Well, we just found some. So let's say this is a graph. And let's say right here is negative 2, right here is 2. was it? I really hate that I can't remember this. But this is basically how it'd be, what it looks like. So no points of whatever is being graphed will be along this line or this line. Now, horizontal asymptote works essentially the same, but instead of it being on the x-axis that we find it, instead it's on the y. But it functions essentially the same. Nothing will be on that line. Now, there are several cases discussed in class. It really bugs me that I can't actually properly wipe away all this blue. Now, case 1. The degree in the denominator is larger than the degree in the numerator, or m is greater than n. I'm going to put n is greater than m. So what that looks like is let's say 2 over 53. That's a case 1. If memory serves, the horizontal asymptote will be y equals 0. Now, case 2, the degree in the denominator is smaller than the degree in the numerator, or m is less than n. So, just to put it easily, 53 over 2. Now, in this case, as x approaches positive or negative infinity, the function of x, or f of x, also approaches positive or negative infinity. If n equals m plus 1, there will be a slanted asymptote. Now, case 3, the degree in the denominator and the degree is the highest exponent. No exponent, the highest number is 1. And you take the multipliers of x instead if it's this case, case 3. Now in case 3, the degree in the denominator and the degree in the numerator are the same value. Rather, the horizontal asymptote is y equals a over b. And that is 5.6 according to my horribly unknowns. Thank you for your time. And have a lovely day.